Good morning students, and welcome back to the session on recursion. So in the last video we saw the working of the recursion using the diagram, the stack diagrams, and the frames getting added and deleted while the functions returning the value. Yes, so in this video, before starting the video, I want to summarize the last video. So we discussed about this recursive case and base case in the must for any recursive function. Yes, and also we discussed how the infinite recursion happens. That is, there are two conditions: when base case is not defined, and one more is the base case is not reached. And also at last we saw the working of the recursion function. Okay, in this video you will see three important algorithms, and we are going to write using recursion function. Yes, that is the factorial of the number to calculate the factorial. The second one is the Fibonacci series, and the third one is binary search. I think the factorial and the factorial of the number and the Fibonacci series we already did in grade 11 using iterative process using for loop. Yes, but in this video you will see how to write that to compute the factorial number using recursively. Yes, okay, how do you define a factorial of a number? It is defined as the product of all the values from 1 to that number. Yes, so n factorial can be written as 1 into 2 into 3, so on up to into n. So let's plan our our program stepwise. When does the n factorial becomes 1? When is the result becomes 1? Obviously when if the n is lesser than 2. Yes, then when is my n factorial becomes n into n minus 1 factorial? When my n is greater than 2. Agree with me? So tell me one application of factorial. Why should we study this computation factorial in programming? One is in the card game. It's very useful. See, factorial of any an item, it gives you the number of ways you can arrange the given item. So where it is exactly used? Let's take any card game. If you want to calculate the probability of favorite outcomes, you have to know the working knowledge of the factorials. Yes, this is one application. Now let's convert our plan to a program over here. So if you see, this is my recursion function. Okay, this is my base case, this is my recursive case. Yes, my base case is a must, both the cases are must for the recursion function. So if n is lesser than 2, as we planned over here, we are returning 1. Otherwise it is going to invoke itself a direct recursion, a recursive call. Yes, that is n into factorial of n minus 1. So this is my program. So whenever call, let's say, it's very simple. Now let's compare this program with the old the for loop over here. Tell me which is more easy. For both are doing the same time, I want you to just analyze the both the way of programming and see which is more easy. I feel recursive is more convenient. Yes, can we move on to the Fibonacci series? Okay, Fibonacci numbers, what is the, it's a very special sequence. We already discussed this also in grade 11. The sequence is it is something like this: 0 1 1 2. The definition is nothing but the sequence starts with 0 and 1. It is the 0th and the first position of the Fibonacci series, and each succeeding number, okay, each succeeding number is a sum of the two preceding number. Let's say my fifth Fibonacci number is 3 because it's a sum of the Fibonacci, my third position and the fourth position. Likewise it goes on. Okay, like we saw the application of the factorial number, there is one application for the Fibonacci number also. One is to calculate the miles into kilometer or vice versa, quickly and roughly. Let's say always the lower number is in the miles and the bigger number is a kilometer in the series. So 2 miles is equals to you will get around, actually if you use calculator, you will get around 3.2 something. So rounding it to, you will get 3. That's what, it's a quick and rough way of checking. Similarly, 3 miles is equal to, you'll get around 5.8 4.8 something, so it's 5. Likewise, so 8 miles is equals to 13 kilometers, 13 miles is equals to 21 kilometers. This is one of the application. Keep thinking, just see what are other application of the Fibonacci series. Okay, I'll explain you. This is called recursion tree. Okay, I'll explain you. Before that, let us see how can you write using recursion function here. So in my Fibonacci recursion function, I have how many base cases? There are 2 base cases. Okay, 1 and over here 2. So yeah, we know the 0th and first position. So when we know, those becomes the base case. Yes, so that is if n is equals to 1, first position 0. If n is equal to 2, my second position, you're going to return 1. This is my base case. So what is the recursive case? It's a sum of the 2 preceding Fibonacci numbers. Okay, so fib of n minus 1 plus fib of n minus 2. This is my recursive case. It's going to invoke the function itself. Are you clear? It's very simple. Comparatively, when we wrote this program using for loop, I feel this is much easier. Okay, in the last video we saw the sum of n numbers using recursion function, and we saw it's working using a stack. We took a stack frames we added and deleted the frames. See, another way is representing this function calls using a recursion tree. This is more simple. So the top of the top node is the number you're going to calculate. Let's say I want to calculate the 5 Fibonacci numbers. Okay, 5 series. Then 5. So fib of 5 will call you will call 2 times. It's going to invoke the fib function. That's a 4 and 3. That's n minus 1. N minus 2. Again 4 we can invoke 2 times, that is n minus 1 and n minus 2. Similarly, you have to keep doing it until you reach the base case. What is the base case? 1 and 0. Clear? This is another way. See, always it's a good practice to trace the recursion using a recursion tree to check whether your program is correct. Your factorial of the number and the Fibonacci is clear. Let's move on to the third technique. This is new. We didn't discuss this technique in our grade 11 and in previous classes. It's quite new. It's a binary search. Very important, a very popular algorithm that uses recursion successfully. It searches a item in a minimal possible comparison when compared to other search technique. The only thing is binary search requires an sorted array to check the item, but whereas the linear search it works for both sorted and unsorted errors. Okay, so this techniques, you have 7 steps. So what I do, I'm going to switch the steps as I read. I'm going to switch between, there's a diagram over in this slide. Okay, I'm going to switch and explain both the slides. Okay, the first point is, as I said, the binary search requires the array to be scanned, must be sorted in any order. It could be in ascending or descending, any order. Second, in binary search, the item is searched in for a smaller segment after every stage. Why every stage is a segment becomes small? Just read the third point, you'll come to know. The first stage, the segment contains the entire array. Yes, see, this is my first iteration, entire array is taken. The second iteration, your segment size becomes small. Let's see why it is becoming small. So to search an item in a sorted array, the item is always compared with the middle element of the segment. Okay, so accordingly, the next iteration, the segment is taken whether the first half to be considered or the second half to be considered. So if the item is more than the middle element, the latter part of the segment becomes the next segment for the iteration 2. Okay, in this case, I'm comparing if the key is lesser than the middle element, then obviously my key will not be over here. Yes, so my low all this will remain the same, but my high will become mid minus 1. Are you clear? High becomes mid minus 1. What happens if the key is greater than mid in the second iteration. Then my low becomes mid plus 1. I will remain the same. It keeps on going until the key is equals to the middle element. Okay, very simple technique. Let's go through the points. Okay, that's the fifth and sixth point. The same process is repeated for the new segment until the item is found. That's search successful. And what happens when the segment becomes a single element and the item, still if you don't find the item, it's an unsuccessful search. So let's see how can we write this diagram using recursion function over here. Quite simple. So there are three base cases for my binary search. Okay, I'm going to pass my array for my recursion function. I'm going to pass the key item which has to be searched. I'm going to pass my lower limit and the higher limit. Okay, what are the three base cases according to the technique which algorithmic technique? If the low, I'll come to this point later. If my key is equal to mid, the item is found. I'm going to pass the index value of that item. If my key is lesser than the mid, obviously my high becomes mid minus 1, which I discussed. Yes, else my low becomes mid plus 1. We already saw this. Yes, so these are the conditions. Then for unsuccessful search, when my low becomes I, that's when there is only one item in my element and the not still finding my key in the array, that's unsuccessful search. I'm just passing returning some random value. Yes, this is my program. So where is my recursive case? I have to invoke my function. It's over here in this step, where when I'm assigning high to mid minus 1, when I'm assigning low to mid plus 1, then I'm going to pass with that new value of low or high. Over two places I'm going to invoke the recurse, my own function call. Yes, so these two becomes a recursive case and this three becomes the base case. And this is very simple. I'm going to store the sorted elements in an array, input the search element, I'm going to pass the array item which have to be searched. Initially we know the index is 0 because already I told you in the first thing I'm going to consider the entire segment. Okay, so I'm going to pass 0 and the length of my array minus 1. Yes, so if the result is greater than or equal to 0, yes, else over here. I think all three are very easily written using recursion function, but there is one let me wind up this video by discussing one disadvantage of recursion. That is, recursion involves additional cost in terms of space used in RAM by each recursive call to a function. Because of the extra memory stack manipulation, recursive versions of functions often run slower and use more memory than their iterative. Yes, this is the only disadvantage. Otherwise, this is not always the case, and recursion can sometimes make the code easier to understand. It's very easy. I hope we discussed enough about the recursion function. Thank you for watching. Goodbye.